Hello, good afternoon. So, welcome back to our discussion in science. So, I need a couple of classes, maybe today, tomorrow. Most of the topics will be over because many things we have already covered in the current affairs, but still, whatever I feel it's important, that is what I am covering. So, current is anyway, I know what are the topics covered in the current affairs. So, today and even tomorrow, I will be starting my session from 3 only, so that most probably I will be able to finish it tomorrow itself, because nuclear tech I have to cover. I am ready with that. So, today and tomorrow, today I may take a bit lengthy session, let us see. So, from 3 we are starting right now. So, we will have a break in between, and then I will continue one more round, so that whatever I could not take yesterday, so today I will covering that also, right. So, be ready, and meantime I know you are preparing for the preliminary exam with full seriousness, not much time left right now. So, revision time, and plus these are a bit of current affairs related, so that is how there will not be any problem. So, please do think seriously and do not give up, and we may talk about one day on how to handle the preliminary exam also. So, maybe today and tomorrow I would like to wind up the science related topics, so that everything what is required in the exam is covered. Okay. So, when we were talking about the satellites, we were talking about the launch vehicles, we talked about PSLV, GSLV, all those satellite launch vehicles, ASLV, SLV3. So, all those things we have covered. Now, a couple of miscellaneous things, and then I will move into nuclear technology. Okay. So, first of all, let me just talk a bit on NISAR, that is NASA ISRO synthetic aperture radar. Okay. NISAR is NASA, NISAR. This is a satellite. Okay. This is it is going to be a satellite to be jointly developed by NASA and ISRO, and that is why the name NISAR. And the deal, okay, the deal was signed in 2014. Okay, deal was signed in 2014, and this is basically this for remote sensing. So, the satellite is for remote sensing. So, basically to observe and understand the natural processes of earth. Okay, to observe and understand the natural processes, that means earthquakes, the movement, the movement on the plate movements, all those things. Okay. So, in fact this is will it is going to be a very very precise remote sensing satellite. So, because it is for remote sensing, observe, understand the natural process of earth. So, to take measurements of some of the planet's most complex processes, okay, to take measurement of some of the complex process, including ecosystem disturbances. Including ecosystem disturbances, ice sheet collapse. Okay, the collapse of the ice sheets. Then natural hazards like earthquakes, tsunami, volcano, landslides. Okay. So, the idea is to take measurements of ecosystem disturbances, then ice sheet collapse, earthquake, tsunami, volcano, landslides, etc. So, under this when under this agreement, NASA will and it will have a under this agreement NASA will provide an L band. Now, we were talking about various bands, Ku S band, C band, L band was also there. Okay. So, anyway NASA will provide L band synthetic aperture radar by NASA, and our Indian ISRO will be providing with S band. Okay. ISRO will be doing with S band synthetic radar. Aperture radar by ISRO. Okay. L band by NASA and S band by ISRO. So, basically it will provide, or NASA will also provide some of the other high communication subsystems. NASA will also provide high rate communication subsystem. Will provide high rate communication subsystem by NASA, and also GPS receivers. A solid state recorder to record the data. Because since it is taking photographs in a particular range, so a solid state recorder is also required, it will be done. Whereas, as I told you, India ISRO will be concentrating on S band radar and the launch vehicle and associated launch services. Launch vehicle plus the launch services. So, it is a joint venture between India and the US. So, that is what. So, this data collected from NISAR will reveal information about the evolution and the state of the earth's crust. It will also help in understanding the evolution and state of earth's crust. It will help in the evolution and the state of earth's crust. Also, it will understand the climate change process to understand the climate change process. It will help in understanding the climate change process, and also the management of future resources and hazard management. Management of future resources, then hazard management. So, this is what we are thinking, and in the process, please remember, we were planning. Now, we were planning to launch this NISAR by using GSLV MK2. Okay, by using GSLV MK2 by 2023-24. So, that was the idea. but unfortunately, but it is 23. Okay. In fact, in 2023 we were planning, not 2023-24, it was planning from 2023. So, we were planning by using GSLV Mk2, and I already told you in August month 2021 this GSLV F10 which failed. Okay, there was a failure, please do not forget. So, there was a failure of GSLV F10, it was a Mark II one, F10 failed, I already talked about it. So, because of the failure of the F10, and since Nisar was planning, we were planning to launch Nisar by using GSLV Mark II, not Mark III. So, this is the failure of this GSLV F10 is a big blow to the Nisar launch. Even though I have already said in the previous class that yes, since our Mark III is also parallelly going on, it may not a big blow to our launch, overall launch, but we had many plans for the next 2 years using Mark II. So, Mark II is not yet perfectly ready. So, that is why we are worried, we are a worried lot, because this is a big program, this is a big plan for us. 2023 we were planning to launch, and it will affect its this plan. That is the only worry we have right now as far as this Nisar is concerned. Okay. So, that is about Nisar. Then another big plan by India is related to RLV, reusable launch vehicle. Reusable launch vehicle, because we are planning for a manned mission. So, even in the manned mission we need the vehicle to come back, and similarly if there is a, see right now what is happening is, say for example, we have a 4-stage vehicle. See, when it starts burning, or rather when we launch the satellite or the vehicle, what happens? Within a few minutes the first stage is dropped. First stage is dropped and it is lost completely. It is dropped in, and it will be detached and it will fall back into the ocean, and it is not recovered. It is not recovered. So, in the reusable launch vehicle, so what happens is, once it is launched, it may reach a particular height, and from there it should come back and it should land back, or it should be at least reusable, or it should be recovered from the ocean. So, if not, it is completely coming and landing back in the in a airstrip itself, or at least it should be recovered from the ocean. So, the first stage, which is the most crucial stage, because first stage we will have to lift the whole weight of the launch vehicle as well as the satellite, everything put together, the entire payload. So, naturally it is a difficult ask. So, we have a plan for developing such a way that if the first stage can be brought down. See, what happens normally is, in normal circumstances when you are launching from the surface of the earth, what will happen? After reaching a particular height, if it comes back, it will re-enter into the atmosphere. When it comes back, it will re-entry. When it re-enters the atmosphere, because of the friction, because of the air molecules, it will catch fire. and it will be completely burned off and some remains may fall into the ocean. But we do not want that to happen, see, because when it re-enters into the atmosphere, it should not catch fire, it should not be, there should be heat shields, there should be heat shields, we should prevent the aircraft from catching fire. Prevent the the vehicle when it comes back, it should not, the vehicle from catching fire, and we should be able to recover it so that we can use it again. So, we have conducted a technology demonstration experiment in 2016, which is known as reusable launch vehicle TD. Reusable launch vehicle TD, TD means technology demonstrator. Technology demonstrator. Ideally, it should come and land back in the air, in the land itself. It may not be that easy, but if you have to splash into the water, it is much more easier. Okay. So, we have conducted a test in May 2016, first test, and so it also requires a hypersonic flight, okay, because it will have to, the vehicle will be coming at a speed faster than the sound, that is the hypersonic. So, in the process, in the 2016 test, we conducted a hypersonic flight. Supersonic means more than the speed of the sound, hypersonic is even higher, okay, hypersonic flight. Then autonomous landing, it should land, of course, we were trying in the water itself. So, autonomous landing, and also the air breathing propulsion. So, we have conducted this test so that ultimately when it comes back, we should be able to, or rather we were also trying to, in the technology reusable launch vehicle, in a reusable launch vehicle, we also want, see, right now what is happening is we are carrying the fuel plus oxygen, we are carrying the fuel plus oxygen or the oxidizer, if not the, so that it is not dependent on the atmospheric oxygen for burning, not dependent on the so right now our launch vehicles are not dependent on the atmospheric oxygen for burning, but in a reusable vehicle we will be depending on atmospheric oxygen. Okay. So, we have to collect and use atmospheric oxygen for burning, then only the weight of the vehicle will be less, and then only it will be able to manage with the in a best efficient manner. So, the purpose of a reusable in a launch vehicle experiment is not only autonomous landing and also the air breathing propulsion. So, this is called, if you collect air oxygen from the atmosphere, it is called air breathing propulsion, propulsion by breathing air. Okay. It is called, that is why I am called, it is called as air breathing propulsion. So, in the technology demonstrator, we tried to experiment the hypersonic flight, autonomous landing, air breathing propulsion. Okay. So, these were the things which was tested. So, in the 2016 test, so what happened is it conducted a test on the, so at the height of we took the aircraft or rather to the launch vehicle to a height of around 43 kilometers at an altitude of 70 kilometers, 43 miles, 70 took a height of 70 kilometers. It is taken on a solid rocket, okay, and then this was asked to come back. So that we were testing that, because right now we do not have the facility to do that. So what we did is we have launched it on a 2 Rohini sounding rockets, a 2-stage Rohini sounding rockets took this aircraft or rather this this technology demonstrator to a height of around 70 kilometers, and then it is allowed to re-enter into the atmosphere, and we looked at the descent, okay. So it allowed from 70, it was allowed to come back from 70 kilometers height from 70 kilometers height, this vehicle was allowed to come back, and then it was allowed to re-enter into the atmosphere and re-entered the atmosphere. And it was again recovered from the Bay of Bengal, okay. So it is a small, so this the RLV, reusable launch vehicle was a prototype, a small version. Prototype means a small version, a scaled down prototype, okay, so that it can be it can be used as a vehicle for crew also, it has to come back. So all these things we were trying in this. So reusable launch vehicles idea is it will go up, and maybe even a manned mission, in a manned mission also it has to come back and we will recover it, okay, that is the idea. So this reusable space plane, we have named it as Avatar. So what is Avatar? Avatar is a single stage reusable space plane. Single stage reusable space plane. So this is what we tested in the reusable launch vehicle, and the idea is the cost of the launch, okay, the per kilogram of the payload, it will come down dramatically. For every per kilogram, every 1 kilogram of payload, the cost of launch will only be 10%, meaning right now some estimates suggest that we are spending around $5,000 per kilogram for launching to the outer space. It may come to become $500 per kilogram. So huge cost difference, 10% cost, that is all if you are able to use a reusable launch vehicle, okay. So let us hope we will be able to do it, and that is the concept, and this reusable launch vehicle will ultimately help in bringing back our manned mission Gaganyaan. When people are taken to the outer space, it is our responsibility to bring them back also. So that is it is a RLV, reusable launch vehicle, was for that purpose, and in the process they also tested a hypersonic flight experiment also. The same test we also conducted a hypersonic flight experiment. Okay. Here we conducted that after taking the whole thing to a height of around 70 kilometers, I already said in the RLV test, and this a flight or rather this machine was allowed to fly at a hypersonic speed, okay, for next 770 seconds. Okay, 770 means you can imagine around 1 minute is 60 seconds. So, around 10 minutes, 11 minutes or maybe 12 minutes. So, say in the first round to take, so it is 770 seconds to take the vehicle to 65 kilometers, 65 to 70 kilometers height. Okay. Then they have then from there at Mach 5 speed it traveled. Mach 5 means 5 times the speed of sound. It was allowed to travel for around 450 kilometers, and then it splashed down. Okay. Mach 5 speed for 450 kilometers is travel, and finally it splashed into Bay of Bengal. But this experiment, this Mach 5 speed experiment which was conducted, it was not to recover. So, there is no recovery done. So, this is splashed and it got disintegrated in water, because if you are hitting the water with such a high speed, naturally it will disintegrate. So, it disintegrated in the water. So, it was asked to steer and travel down at a speed such a way that it achieved a speed of Mach 5 speed. Mach 5 means 5 times the speed of sound for around 450 kilometers traveled and flashed into the ocean. Okay. So, that is how the hypersonic. So, we were able to achieve around 65 kilometers above, 65 to 70 kilometers height, it got separated. It started flying at a hypersonic speed, traveled for around 450 kilometers and finally splashed into the ocean. So, the heat shield, navigation, control, everything was tested. It tested. In the process, we could test the heat shield, navigation, etc. was tested in this experiment. Okay. So, when it, especially when descended down, naturally it might have been encountering lot of heat because of the friction with the atmospheric molecules, and we were testing all those things. Okay. So, this this is called hypersonic flight, and it is also known as a scramjet. Supersonic ramjet. Okay. Supersonic ramjet, or it is also known as, what do you mean ramming? So, when the aircrafts fly, you might have seen they have along the wings, air will be ramming into it. But here, if you are able to achieve supersonic speed, then we call it as supersonic ramjet. So, we are in a jet aircraft, in jet aircrafts, atmospheric oxygen or air is rammed into, hit, it will be hitting into the engine, rammed into the engine. Okay. That is what we call it as the air breathing propulsion system. It is breathing air, that atmospheric air is used for and because the intensity of the because the speed it is ramming into it, it gets compressed, the air will get compressed. So, then we call an air breathing propulsion system. Okay. Air breathing propulsion system. And then, so this is also conducted in 2016. Okay, this air scramjet test or scramjet technology was also tested by ISRO in 2016 in a separate experiment. In 2016 we conducted the scramjet technology also, and India is the 4th country to test the scramjet technology. India is the 4th country to conduct the scramjet technology, and if you look at the US, Russia, they have it, but India is the 4th to do that, and in the reusable launch vehicles we need scramjet technology. Okay. Scramjet technology is used, and when the aircrafts travel beyond the 3 Mach speed or beyond 4 Mach speed rather, then what will happen? See, normally in a jet aircraft you can see a rotating blades from the front of the aircraft. When you see these blades are rotating at high speed to increase the pressure of the air. So, it is according to experts, if you are using, if the speed is more than 4 Mach, then there is no need for rotating blades, there is no need for rotating blades to compress the air. The speed, if speed is more than 4 Mach, then there is no need for rotating blades to compress the air. Okay. So, this the speed itself, the speed will help. So, the airflow would be compressed by the forward velocity of the machine itself. The aircraft machine will the speed of the aircraft will help in compressing, the speed of the aircraft will help in compressing the air, and which will be sufficiently giving the thrust for the air vehicle to move anyway. So, that is how by then you can even use hydrogen fuel or any of these fuels which can be used. So, the air flow would be compressed by the forward movement of the rocket and its aerodynamic design, and the normally hydrogen, when the air enters with such speed, hydrogen is used as the fuel. When air enters with high speed, it is compressed and hydrogen is provided as the fuel. And the burning air, okay, the hot air which burns, it will expand. Okay, when it is released out, it will expand and it accelerates the exhaust and it will create the thrust. Okay, anyway, so we need not get into the details of that. So, but what is found is an air breathing scramjet engine using hydrogen will be at least 3 times more efficient than the conventional liquid or solid rocket. This air breathing supersonic scramjet, the air breathing supersonic scramjet can be at least 3 times more efficient than the solid or liquid rockets. Okay. So, anyway, so that is the concept of the scramjet. We have conducted a test in 2016. Let us hope we will be able to develop it properly, because that will be very crucial for our reusable launch vehicle. Again, experiments are going on. If you are sending, if you have to send our crew to the space, naturally we will be requiring these reusable launch vehicles. That is the idea behind the whole thing. Now, let us come to a bit on Chandrayaan 1 and 2. Chandrayaan 1 and 2. So, it was launched, Chandrayaan 1 was launched in October 2008, PSLV C11. PSLV C11, and it reached the lunar orbit on 8th November 2008. And we also conducted a impact mission, okay, on 14th of November 2008, a moon impact mission. After reaching the moon's orbit, the launch vehicle, the one stage, the last stage of the rocket was dropped onto the surface of the moon. The last stage was dropped onto the surface of the moon. The last stage is dropped onto the surface of the moon along with an Indian flag. So, India became the 4th country to place and in our our flag on the surface of the moon. Okay. So, when US and Russia were the first 2 countries to do, and then India became the 4th to do that. China has also sent their mission onto the moon. They could descend something and they could land it properly also. It is an impact mission. We dropped an equipment onto the surface of the moon, and the place where we are dropped is known as Shackleton crater. Shackleton crater, and the place or in the region is called Shackleton crater, and the place where we dropped our equipment and the flag we have named, it was in 2008. So, during the UPA government's time we have named it as Jawahar crater. Had it been today, during Modi government's time, it would have been Deen Dayal crater or Atal crater, और नहीं तो खुद अपना नाम दे देता Modi crater. Okay. So, since it was the Congress time, they have named it as Jawahar crater, because it is dropped on 14th November. It is coincidental that it has happened on 14th November. So, since Jawaharlal Nehru's birthday on that day, the then government named it as Jawahar crater. Today it would have been Modi crater or whatever it is, I mean Deen Dayal crater or anything other than Jawahar crater would have been there. So anyway, so that is how we have done it. And we have also, and along the mission there is a remote sensing satellite, and it revolves around the moon. A remote sensing satellite is also launched, it revolves around the moon, and that is what the Chandrayaan mission we were talking about. And this lunar mission had many payloads from other space agencies also. It had 6 payloads. Okay, 6 payloads are there. Somebody is saying it could be named as Ambani crater. हो सकता है Adani Ambani crater also could have been, by saying that they paid some money, because everything is on sale right now. So we will be able to sell road also, train also, a port, everything you name anything, stadium, everything is on sale now. Government is saying it is not on sale, but it is actually on sale. It says the national monetization pipeline is about the property will be owned by the government, but used by the private players for 30 years, 40 years and all. After that there will be nothing left to nothing left in the asset. So that is what Kaushik Basu has said, it is called asset stripping. That is what Kaushik Basu, the former chief economic advisor during the previous governments, he has said that this will result in asset stripping, because if you are giving an asset to somebody for 20 years, 30 years, they will try to extract maximum from that. They will strip out, they will take out maximum assets from that during their usage, and what will be given back to the government after 30 years or 40 years will be only the skeleton. The real juice would have been taken away, the flesh and blood would have been taken away, only skeleton will be given. And Kaushik Basu, the former chief economic advisor to government, he has suggested the name called asset stripping, and you can just look into that, very interesting thing. Okay. So that is a different thing. So asset monetization as an idea may be very good, but if you are doing the way we are planning to do, see, if it is resulting in cartelization, if it is resulting in the assets getting accumulated in few hands, if it is creating monopoly, then this will lead to crony capitalism. It is the worst form of capitalism. Crony capitalism, the near and dear ones of the ruling party, if they are getting all the benefits, that is called crony capitalism, and crony capitalism is the worst enemy of any democracy, and if it happens, our assets will be handed over to such people and it can be disastrous. Anyway, so now our concern is Jawahar crater, that is where it was dropped, and tomorrow if everything is privatized, even the polar satellite PSLV is also going to be privatized, it seems. Private players will launch PSLV, so Adani SLV, then Ambani SLV, all will SLV. Even in fact, in the Adani, in PSLV privatization, Adani, sorry, ASLV लिख दिया मैंने, Adani, L&T, and I don't know, one more company has showed interest in commercially building PSLVs. So we don't know. Anyway, so this is the situation anyway. So this is what we are on, this Chandrayaan. But within 1 year, this Chandrayaan mission, so it had 2 things, one an impact mission, another one revolving around the earth, moon in an orbit, it is a remote sensing satellite, and using the equipments in that Chandrayaan 1, while the impact was conducted. So when we dropped the engine onto the surface of the moon, it went down and hit the surface, and it resulted in kicking up some dust. Using a spectrometer within the within the rotating or within the revolving Chandrayaan, they studied, and NASA and ISRO jointly declared the presence of water on the surface of the, or declared the presence of water in the subsoil of moon. Because of this impact study, I am repeating, we dropped the engine, the rocket's fourth stage was dropped into the surface of the moon along with the flag. So, it kicked up lot of dust, okay, kicked up a lot of dust, and the dust was analyzed by NASA and ISRO scientists by using some spectrometers, and they declared the presence of water in the subsoil of the moon because they could easily identify OH minus. See, H2O, water is H2O, that is nothing but H plus and OH minus. So, hydroxyl ions. So, this OH minus or okay, they could discover hydroxyl ions from the dust which is kicked up, and that is how the presence of water on the surface of the subsoil of moon was been confirmed for the first time. So, NASA and ISRO both the both the agencies claimed that there is enough evidence to suggest that there is water in the subsoil of moon. This study was conducted with the help of the Chandrayaan-1. So, the biggest achievement of Chandrayaan-1 is they could reconfirm, they could revalidate the presence of water in the subsoil of moon. They could revalidate or validate the presence of water in the subsoil of moon. So, that is a big thing. Okay. That is a big achievement because they could identify hydroxyl ions, and this is because of the Chandrayaan-1 experiment. Okay. Now, again Shackleton crater is the larger place on the surface of the moon. Okay, the whole place may be called Shackleton crater, and the place where it is dropped, the exact location of the dropping of our ISRO equipment or the last stage, the fourth stage of the rocket, it is called Jawahar crater. So, Jawahar crater is within Shackleton crater, and Jawahar crater is the exact location where we dropped the last stage of the lunar mission, and that is how it is named. Okay. So, Chandrayaan-1 unfortunately could not complete its 2-year cycle. It we lost contact with it in August, 29th of August 2009. It reached on 14th of November 2008, around that time. So, till 29th of August it functioned. So, since then it could not function. So, Chandrayaan-1 was there for less than 1 year, even though the plan was for 2 years. So, the mission was completed, or it was declared as completed on 29th of August 2009 because of a power failure, okay, technical issues. Okay. Thermal shielding was a problem. So, because of certain technical issues, on 29th of August 2009, India declared that the Chandrayaan mission is over. Mission over. So, that is how Chandrayaan-1, but still it was considered to be 95% success because it worked for almost 312 days, and we could help in confirming the presence of water in the subsoil of moon by studying or by analyzing the dust kicked up by the dropping of the fourth stage of the rocket onto the surface of the moon, and that is how the significance, that is why the whole mission was highly successful, that was the significance of it, right. So, that is situation. Now, coming to Chandrayaan 2, that is the second mission we had. So, please remember Chandrayaan 1 by using PSLV C11. Now, Chandrayaan 2 and it is planned for a lunar orbiter. It will revolve around the moon. Also, we were planning for a lander called Vikram, lander, and a rover called Pragyan rover. So, Chandrayaan 1, the place where it is landed, the crash landing was Jawahar crater. Chandrayaan 2, it is different, okay. And it is land in the Manzinus Sea on what is that Simpleus. So, anyway, that is the location where we are planning, but nothing happened because it got crash landed, and the lunar orbiter is still functional, still working. Vikram lander and Pragyan rover, it failed, it crash landed. The last 2-3 minutes it could not work. So, the Vikram lander and the Pragyan rover got failed. Anyway, so the main objective was to map and study the various or the variations in lunar surface composition, to map and study the variations in lunar surface composition. And also the location and abundance of lunar water. Okay, one is map and study the variations in lunar surface composition, and the second point, the location and abundance of lunar water. So, and we launched it in on 22nd July 2019. So, second mission, the lunar 22nd July 2019 by GSLV Mk3 M1 Mark III M1, and it reached the orbit in August 2019. And we were supposed to launch, or rather descend down and land on 6th of September 2019 on the near side of the moon in the south polar region. We were supposed to land safely. Yeah, the fourth stage, obviously there are only 4 stages in the, now if it is GSLV only the third stage, but since we were launched PSLV at that time, the fourth stage was dropped for the impact mission. Anyway, and we would have been unfortunately we could not, the fourth country with a successful soft landing means we would have been the fourth country in the world after USA, Russia and China to land safely on the surface of the moon. Okay. So, there is a software glitch. Unfortunately, on 6th of September, when we planned our mission to land, it could not land and it failed. Okay, that was on 6th of September 2019 because of a software glitch. The last moment we could not. So, we are planning for a Chandrayaan 3 now in 22-23. We are planning so that is on in 22-23 we are planning Chandrayaan 3 anyway. So, that is situation. So, we wanted a lander, Vikram the lander, Pragyan the rover. Rover means it will row, it will travel after landing. Pragyan rover would have been, it is like a small robot, it will be moving around on the surface of the moon. So, that is what we wanted, it will roll around, it is a rover, but it could not reach or it could not land properly, it got destroyed. Now, coming to Mangalyaan, Mangalyaan. So, this mission by India which reached, it is launched on 5th November 2013 by using a PSLV C-25 on 5th November 2013, and again India's first interplanetary mission Mangalyaan. So, again the fourth country to achieve this after USA, Russia and European Union, or the fourth space agency to do that, NASA and then Roscosmos and European Space Agency. And the first country, first Asian country to reach the Martian orbit, first nation in the world to do in the maiden attempt, the first attempt itself we made it. Okay. First country to achieve this in the first attempt itself. So, we used a PSLV C-25, okay. We use PSLV C-25 for launching it. So, it took almost 300 days, 298 days to transit to Mars, okay. Almost 300 days to reach the Martian orbit anyway. And the objective, so it was a technology demonstrator. What were the objectives?